Okay. Good evening and good afternoon to anyone joining us on this call today. On behalf of the International Dysphagia Diet Standardization Initiative, I'd like to welcome you all to tonight's webinar titled Using the IDDSI Flow Test in a Clinical Practice. How thick is thick and does thickness really matter? This webinar is presented by Carly Barbon. We would like to thank you, first of all, the listeners for being here today and spending the next hour with us exploring the IDDSI Flow Test. We would also like to thank our very generous sponsors who allow the work of IDDSI to continue, and you can find more about them on our website, iddsi.org. Some quick housekeeping. This webinar is being recorded and will be available on our website at the end of this week. And second, all participants joining us today are in listen-only mode. And this means that the panelists will not hear or see you at all throughout this call, and that your microphone and your video will remain off. If, however, you have any questions throughout the presentation, you can submit your questions while the presentation is happening. And to do so, you can click on the Q&A button on the middle of your menu bar at the bottom of your screen and submit them to the panelists. And then the panelists will address these questions as they see fit, either throughout the presentation directly to you via the chat mode, or at the end of the presentation when we will have about 15 to 20 minutes to do a Q&A period. Also, in the upcoming days, a certificate of attendance will be emailed to anyone attending this session via a computer. So I can see that there's a couple people joining us through a phone line. So please do email us to let us know who you are so that we can email you the certificate. Okay, now moving on to our main presenter for this session. Carly Barbon is a speech-language pathologist and a PhD candidate in the Swallowing Rehabilitation Research Laboratory under the supervision of Dr. Katrina Steele. Carly has research interests in texture modification related to swallowing in patients with head and neck cancer. Carly also has clinical experience with swallowing in a variety of patient populations with a background in measurement of viscosity and flow of liquids. She has extensive experience in accurately testing liquid thickness using the IDDSI flow test. And when she is not doing research, Carly enjoys sipping on a morning IDDSI level 0 coffee or the occasional level 1 slightly thick smoothie. Also joining us on this phone call are Peter Lamb, Jan Duberstein, Julie Cicero, and Dr. Katrina Steele from the IDDSI Board of Directors, who will be listening in and answering any particular questions about the framework, the IDDSI framework, and the flow test and implementation during the Q&A sessions. I think that is it for me for housekeeping. So without further ado, I now present to you Carly Barbon. Carly, go ahead.
All right, thank you so much, Alan. Greetings from Toronto. Thank you so much for joining in today. I'm really excited to be talking to you about texture modification and the IDDSI flow test. I've spent many hours liquid testing in the lab, and so I have a few tips that I can't wait to share, and hopefully they'll make your testing process a little bit easier. So let's get started. And before I get started talking about IDDSI testing, I have to really give a nod to the IDDSI Board of Directors, many of them who are here right now online and come from a really wide range of backgrounds and specialties. And they really have one common interest, and that is standardizing the measurement and the classification of food and liquids for dysphagia management. So today's learning intentions have one common theme, basically to better help clinicians and patients feel confident and empowered to use the IDDSI flow test, whether it be for implementing a texture modified diet at home or creating contrast stimuli to match video fluoroscopy recommendations. Today I'm going to be focusing on just the liquid aspect of texture modification for this particular webinar. So there's been a growing amount of research in the field relating to texture modification and our need to really have a standardized system. This initiative really began with IDDSI's first publication, which stated the need for an international system for liquids and foods. So most of us have had the unfortunate event of a patient transitioning from a hospital or long-term care facility where they've presented and had inconsistencies in their diets. And so the lack of standardized nomenclature is quite confusing. We know, and research has proven, that it's really difficult to be consistent with developing the traditional honey or nectar thick liquid within our own mixing, not even just SLP to SLP or dietitian, but within our own ability to consistently reproduce a nectar or a thick liquid in our targets. So next, IDDSI conducted a systematic review, which demonstrated the evidence that thickening does overall help those who aspirate on thin liquids. One longstanding problem is that one commercial product is not really the same as another, of course. And so IDDSI really examined many samples and recipes from manufacturers, and products do vary significantly. Now, historically, this has caused confusion for a lot of caregivers and individuals with dysphagia. So there's a lot of great research going on, but unfortunately, because different terms and definitions are used and also different ways of testing, we're unable to accurately compare and really draw valid conclusions from the results of the research findings. And so this systematic review really led to the development of the IDDSI framework, which includes terminology and really outlines texture modified foods and thickened liquids. All right, so here are the highlights of the systematic review. And essentially what we end up with is a Goldilocks dilemma, where we don't really know how thick is too thick and vice versa. And so I'm gonna ask you, how do we really traditionally evaluate the thickness of a liquid if you're in a hospital setting? And while you think about that question, I'm also going to ask, are we accurate? And how do you even know? And so also, to add to that question, what happens when we add barium to the mix? And so there are a lot of questions that we don't really have answers to, but this is how IDDSI can really help us to remain consistent and to determine the best consistency for our patients, and also really make it clear and objective for both the patient, the family, and the clinician. So why thicken liquids? We know why we thicken, and we know that it can help our patients who have difficulty on thin liquids. Now, clearly this swallow that we're seeing doesn't necessarily require thickened liquids. I just wanted to post my own swallow and brag about it a little bit because it's pretty nice. But overall, how can we accurately test thickness levels and translate those beneficial thickness levels to our patients? We use video fluoroscopy to determine what we need to provide the patients, but then we have trouble with liquid preparation in terms of how is what we're giving them in video consistent with then what we're recommending. So few questions that we ask. What are we mixing? How do we know what we can see? So how much barium do we add? How does this impact flow for our future recommendations? So these are all extremely important questions, and I aim to help answer these during the course of the webinar. And so I'm going to get back to contrast, but right now I'd like to review the IDDSI framework really quickly with you. So the role of IDDSI is an important one. It allows us to work with that Goldilocks dilemma that I was mentioning with the patient online. So today I'm going to talk to you specifically about texture modified liquids. And how we can really use the IDDSI Flow test to aid in our video fluoroscopy standardization process and our clinical recommendations. So we're all familiar with modifying liquids for patients, and hopefully I can make this a little bit easier. And today I'm going to be focusing on the bottom triangle outlined here in red. The triangle works its way from the fastest flowing liquid seen in the bottom, that 0 level thin, and all the way to the top is the slowest flowing liquid and overlaps with the food pyramid. One thing that I will mention is that the IDDSI framework and the IDDSI Flow test, is not a test of viscosity. So a word that is used a lot in our field is viscosity. And so we really have to shift our minds in this IDDSI framework framework to talk about flow when we talk about consistency levels rather than talking about viscosity. All right, so our literature does contain a lot of studies where lower technology measurements of liquid flow have been used, and these include the line spread test that you can see here on the left of the screen and the Bostwick consistometer that you can see on the right. Now, both rely on flow of liquid across a level surface, and each device involves determining the distance of flow over a specified time period. This slide here shows how Bostwick measurement works. The liquid is placed in a small holding chamber, and when the gate is released, it flows into a longer measurement chamber marked with distance measurements in ½ centimeters. And so distance flowed is conventionally measured in 30 seconds. Now, a lot of places, especially Quebec still use this method. However, it's quite messy and it requires a lot of test stimuli. So I've been doing some testing with it, and I believe it's 60 mils or more just for one test. And so it's very time consuming. You have to clean it. You can't submerge part of the level underwater. So it does take a lot of time and a lot of energy. Speaking of flow, with the guidance of Dr. Ben Hansen from University College London, the IDDSI committee settled on a simple flow test using an empty 10 milliliter syringe only. This test is modeled after a flow testing that's used in other industries, which uses specific funnels to measure the thickness of liquids. So historically, the posthumous funnel was used to measure the viscosity of yogurt. A predetermined amount of liquid was allowed to flow through the funnel, and the time to exit the funnel was measured as an index of apparent viscosity. So to perform the IDDSI flow test, you plug the bottom of the syringe and fill the chamber with 10 milliliters of your test fluid. When you're ready, you release your finger from the nozzle and you allow fluid to flow out of the syringe for 10 seconds. After those 10 seconds are up, you're constantly watching the timer. You replug the nozzle to stop the flow. So the amount of fluid left in the syringe determines the level on the IDDSI framework. The test works really well for discriminating between levels 0, 1, 2, and 3 that you can see on the right hand of the screen. At level 4, there essentially should be no flow. And at this point, IDDSI recommends that you move to either a fork drip test or a spoon tilt test, which is also described on the IDDSI website. And I'll also be doing some testing with you in a little bit. But first, I'm going to let you know exactly what you need to set yourself up for successful liquid IDDSI flow testing. So, the first piece of information I have to share is that syringe length is critical. So just because we test with 10 milliliters of flow from a syringe does not mean that you can fill a 60 milliliter syringe with 10 milliliters and perform the IDDSI flow test. Syringe length, you have to make sure you have a 10 milliliter syringe only. That's my very first step of the IDDSI flow test hierarchy of things that you need. So number 2, now that you have your 10 milliliter syringe, we need to ensure that it is the correct 10 milliliter syringe. So what I mean by this is, although you have 10 milliliter syringes and it's the measurement of fluid, they're actually not all identical. So although 10 milliliter syringes were initially thought to be identical throughout the world based on reference to an ISO standard, it has actually subsequently been determined that the ISO document referred only to the nozzle of the syringe. And so the variability in barrel length and dimensions may exist between syringe brands. So specifically, the IDDSI flow test uses a reference syringe with a measured length of 61.5 millimeters from the 0 line to the 10 milliliter line. And BD syringes were used for the development of this test. So the manufacturer code can be seen here in red. And I have some others to share with you as well. And IDDSI is aware that there are some syringes that are labeled as 10 milliliters, but in fact have a 12 milliliter capacity. And so the result of using a 12 milliliter capacity syringe will be different from those using a true 10 milliliter syringe. So as a result, it's extremely important to to check the barrel length. And on the next slide, I will show you how to do so. So you can always measure the length of the syringe using a ruler to ensure the height of the column of the syringe from 0 to 10 is equal to 61.55 millimeters, like you can see there on the left. Or if you have the IDDSI card, it's a standard card that's usually given out at IDDSI talks or at different meetings or conventions. As a part of this IDDSI card here, you can actually align your syringe up with the ruler on the left of the card, and this will ensure a proper syringe length. It's really, really handy. And so if you don't have one, it'd be great to grab one if you see any of the IDDSI board members at any conferences. Another way to ensure that you're working with the right dimension is that 10 milliliters of water will exit the correct syringe completely in 7 seconds. And so that's a really nice way to ensure that you've chosen the right syringe. And it's just a really nice calibration tool. Even once your syringes get old, things like that, it's always a nice test to have. I've also provided a list here of the current product codes, and to just be aware that they are new product codes. The syringes are the same in terms of their dimensions, but the shelf carton sizes have changed. So it's just important to be aware of these codes for ensuring the correct syringe type. So you have the current product code available to you here in both the slip tip and the lure locks, and those are the tip types that I'll be talking about in the next slide. And then you have the new product codes that they had been transitioned to. All right. So not only are syringes important, but so are the types of tips that you use. So here's another step in ensuring that you're getting the most out of your IDDSI flow test and that it's correct and accurate. So because we're working with flow, these are really important details that can't be overlooked. So here are the types of syringe tips that are acceptable and will provide you with consistent and accurate flow measures. So first we have the BD lure lock. And this is that has a kind of a circle around, kind of like a barrier around the tip of the syringe. We have the lure slip tip, which is my personal favorite. We have the eccentric lure slip tip. And so you can use all 3 of those tips, provided that your barrel length is the correct length. And so provided that you have the correct barrel and everything, the height of the syringe is 61.5 millimeters, then you can go ahead and use any of these syringe types tips. However, the catheter tip is a no-no, so this does not qualify as a tip to use for IDDSI testing. All right, so I have a couple of mixing tips and tricks. I am going to assume that most of the people who are viewing have tried the IDDSI test, and if not, I'll be showing some of that in a little bit, but just some kind of mixing tips and tricks to start off. So one of the things that's that helps me is pre-measurement of thickeners. And so it's not necessary. However, if you're working on development of recipes for use within a facility, pre-measured thickeners may help you out just to kind of standardize that process. And so you know how much of a thickener you need to create a level, 1, 2, 3, and 4. And I also, in terms of, research and things like that, but even clinical sense, recording small changes in thickener also helps in order to recreate or work on tweaking certain recipes that you have to make them a little thicker, to maybe meet the middle, maybe you're kind of on the edge of a 1 and a 2 and you want to get up in the 2, so small changes are really important. And if you're making recipes that you'd like to have for your facility, this might be a good idea to just record those changes. And Pre-packaged thickeners and scoops are really great, but for accuracy and consistency, I highly recommend using a scale, especially in the hospital setting. This is because some thickeners have grains of various sizes, and I've noticed that some of the scoops that I take are way more or less than what the full scoop should be. And so most of the thickening cans will have the amounts on the side of how much a scoop should be, but I always really like to be careful, and I like to weigh my thickener. Also, when making textures such as slightly thick or level 1, which aren't really common as pre-measured thickeners because they're not really widespread yet in terms of that slightly thick consistency, it's really best to use that scale. Again, I always weigh my thickeners to 2 decimal points, even 1 would be fine, really for clinical recipes. The use of thickeners is also sometimes quite finicky, and working with them can really prove difficult in terms of how much you're adding to your base, whether that base be water, juice, a liquid with fat content like milk. The typical thickeners we use are usually starch and gum. And they may behave differently when fats and sugars are added. So I recommend playing around with recipes for first thickening water and then expanding into other beverages that may be provided to your patients. This way they can have a general boundary of thickener amounts for each IDDSI level, since the flow can really vary between each of IDDSI's lower and upper boundaries. So all of the above, so the bubbles, the chunks, the barium, all of these can really change the flow of the liquid that you're testing. And there are a few ways that we can overcome some of these issues in our samples. So bubbles are really variables that can alter the flow and the corresponding IDDSI flow test results. And so you may end up with a different consistency that isn't true to the liquid that you're testing. So when you're using a syringe to draw up a sample of thickened liquids, bubbles can occur if air gets mixed and trapped within the sample. This is also something that can occur when mixing in a thickener, particular gum thickeners. And so in order to prevent bubbles in a test sample that you're going to end up testing with the IDDSI flow test, you should really make sure that there's enough liquid in the sample that you're drawing up. And so what this will help to do is it will help prevent air from entering the syringe. So I always make sure that I have ample test fluid, and I just submerge the syringe in there, and I make sure that it's not touching the bottom of the cup. So that way I have the syringe kind of suspended in the liquid while I'm drawing the liquid up. And that for me eliminates a lot of the bubbles. When you then deliver the sample into the flow syringe, or sorry, the flow test syringe, so the flow test, the syringe that you'll be testing with, excuse me, I always press the nozzle of the syringe that I'm loading with to the side of the test syringe to make sure that I can load the sample against the syringe and load it slowly. And I'll actually be I'll demo some of that for you in a little bit so that you can kind of see what I mean. Another issue is with lumps. So one of the main challenges with syringe testing has been making sure there are no lumps within the stimulus. But even if there are really small lumps loading within or floating within the suspension, this can really alter or impede the flow of the liquid through the syringe. So I've had times where I've had chunks of thickener left over and it's gotten caught in the tip, and I notice a slight halt in flow. It goes through the syringe tip and then it continues flowing. And so right there, I don't have a true flow test result because the flow has been altered at some point. So then I have to just remeasure and redo the flow test. And so there are a few ways actually to decrease the risk of having lumps in your stimuli. Number one is that ensure that the liquid is moving at the time that you pour the barium and or thickener into the medium. So I always have my water moving, and then I add in my thickener slowly. And so that actually helps to disperse the thickener, and so you don't get a lot of those chunks that you would normally have. while the liquid is moving, you can also either pour the pre-measured barium in if you have contrast, and then the thickener, or you can actually pour them into the water at the same time. But again, I always also have everything added to the liquid. So don't add liquid to powder. It's always powders into liquids. That way nothing gets stuck on the bottom. You're not scraping and causing more lumps. And so you can also mix together, again, the pre-measured barium powder with the pre-measured thickener, mix the two, and then add them in as a single mixture into the moving water. So those are kind of some of the things that you can do to help ensure that you don't get as many chunks. So in this next slide, I'm demonstrating the two loading options that I was talking about in terms of loading with the syringe against the syringe tip against the syringe. So one of these options is the best way to avoid bubbles. Hint, it's in the green highlight. On the left, the liquid is being loaded with a lure lock syringe. So that tip has a bulky plastic shield around it, where the one on the right is a slip tip syringe and is just the tip with no circular shield. I'm going to draw your attention to a few things. So notice how the liquid flows in each of these examples. So in the picture on the right with the green, I'm able to take the slip tip loader syringe, press it against the test syringe, and have it flow against the wall. In the picture on the left, I'm really unable to get approximation of the tip of the loading syringe to the wall of the test syringe. And so the difference here is that the liquid in the left is kind of free pouring, while the picture on the right, the liquid is running down the side of the syringe as it's being filled. And this small difference can actually help with the struggle of getting bubbles in your sample. And so I'm actually going to show you that right now. If we can actually go live, Alan, that would be great.
You bet.
Perfect. All right. So okay. I have some, let's see. Okay. So I have some liquid here, and I have, it's some thickened.
Sorry, Carly, before you keep going, I think we need to make sure that your video is full size, because I think we can still see the presentation right now.
I'm going to stop share.
There you go. Perfect.
Great.
That's great.
How's that?
That's great.
Is that good?
Thank you.
Okay, no problem. So what I have here is a lure lock and a slip tip. So this lure, they're both filled with a thickened soy milk. And so I'm going to show you the difference between loading with the lure lock versus the slip tip. So with the slip tip syringe, as I had mentioned before, so this is kind of how I load. I cap with my pinky and I hold the syringe towards me with the 10 milliliters towards me so that I can see how much I'm loading. Now, when I load this syringe, I load against the test syringe. And so in doing this, it helps to eliminate any bubbles because I'm actually pressing it against the syringe. And this is a trick that I found has really, really helped me to be able to test the liquids. And so I'll just kind of demo here that I would have my phone, I would press start, and I would let the liquid go for 10 seconds. After 10 seconds was up, I cap the syringe with my pinky, and I'm at a 9. So this would technically be a moderately thick liquid or level 3. Now, I'm going to show you how that helps filling the syringe rather than having a lure lock. It's just my preference, but a lot of the times people like to fill the syringe just kind of down and pour. And so what that does is sometimes if you have a little bit of a thinner liquid or a more finicky liquid, that will cause clumps or bubbles just by loading straight down. With this liquid, it's not too bad. with the luer lock, you also can't get towards the side as well. So you really have to shoot it against the side if you're gonna load it that way. But those are just some of the ways that you can work to eliminate some of those bubbles that you might get. While I'm live and while I'm on video, I'm actually gonna show you one more thing. So this kind of goes to the notion that just because a texture can go into a syringe doesn't mean that you can test it using the syringe. So what I have here is some barium pudding that I had one of my colleagues save from our video fluoroscopy. So this is 100% weight to volume pudding. And so what happens here is when you go to put the pudding into the test syringe, you get hang up of the consistency throughout. So it's not touching some of the walls of the syringe. It's really not going down. And even if I bang it against the counter, it's just not going to go in. And so really what I'm just trying to say is that just because I can suck it into the syringe, I think this would warrant moving towards the spoon tilt or the fork drip test. Okay. All right, Alan, I am ready to go back into the other mode.
That's great. So if you can just share your screen again and then go back into your presentation.
Perfect, thank you.
Mm-hmm.
Great.
Perfect.
Okay, thanks so much. So here's another example of how I just kind of showed you loading the syringe can impact your sample. So in this example here, I've loaded with a slip tip, but I didn't press the tip against the side while I was loading. And so you can see these little bubbles here forming throughout, and you can really see them as you turn the syringe around, they're everywhere. And so my point being is that all of these bubbles add up and they do have the potential to impede the flow of your test. So just some other FAQs, frequently asked questions that I've gotten with some of the posters that I've had on IDDSI testing and things like that. Can I use a larger syringe? Everybody say it with me, scream at the top of your lungs. I wish I could hear you. No, it has to be 10 milliliters. The barrel has to be a certain length, 61.5 millimeters, and you cannot use a larger syringe. It has to be 10 milliliters. Can I reuse a syringe? Well, you absolutely can. The answer is yes. However, you can reuse it until it looks like this. I often, because of the amount of testing that I do, the ink runs off of, or gets rubbed off of the outside of the syringe. But the issue is that I'll usually use these syringes as the loading syringes, but really once the numbers rub off, it's time to open up a new package because, in terms of the integrity of the plastic and things like that, at this point, it's better to just chuck it and use a new syringe altogether. So in regards to the other questions, how many times should I run a liquid? Since the test requires very little test sample, I like to run my liquids 3 times and take the average of those 3 runs. Typically, if the liquid has a larger outlier, so let's say I do 2 runs and both runs are pretty much hovering around a 5, and then I do the 3rd run and it's 6.6. That's a little odd, so there may have been a clump or there may have been a bubble. So I'll go ahead and rerun that and then use that last run as my average. What kind of timer should I use? I always use a touch timer. When I first started testing, I played around with a few button timers that we had, and I really found that I lost a lot of my runs to just error because the button wasn't pressed, or I pressed it and I didn't think it was on, so I pressed it again and it stopped. So just use a touch timer on your phone. You will thank me later. And then in terms of washing syringes, I fill a sink usually with soapy water. And as soon as I'm done with one syringe, I throw it into the sink immediately just to prevent you know, prevent from any of that buildup and things like that from getting, you know, into the syringe. For each test, even with the same liquid, I always use a clean syringe to ensure an accurate flow test. And once I'm done with all of the three, I pump water into the syringe 3 times with the plunger, and then I rinse it with warm water twice. Clean warm water, and then I set them to dry. And I'll also mention that you never want to use a syringe to test that's still wet. So I'll come in the next day, want to test some more. I will always use a clean, dry syringe, even if I have to open a new one, because I never like to, you know, spoil any of the results or dilute anything. So I just stay away. If the syringe has water in the tip or the barrel and it can't be removed, I wait until it's fully evaporated, and I'll just use a new syringe. So here are some tips for using contrast. So these are things that I really stick to, and they make my life a lot easier. So I always add my barium to my medium, my liquid first. And I always make sure that it's moving. The water is moving, and I add everything together as the water's moving. Following thickener instructions is important. And I really try to ensure that there are no barium clumps when I'm using the powdered barium. So sometimes I'll go in after I measure my powdered barium with a fork just to distribute, you know, and make sure that there are no clumps or big chunks that have formed, and then I pour it into the water. I always make sure that I stir my contrast before IDDSI Flow testing. So this goes both ways. Making sure if you're using a liquid barium that you stir it or shake it quite vigorously to put in your water, your mixture. And then always before testing, making sure to stir, because what's going to happen is some of that contrast is going to settle on the bottom, and you won't get the most accurate flow test result because you're missing some of that barium density within your stimuli. So this table demonstrates the IDDSI syringe flow test results for Bracco's Verabar barium products. They're not available in Canada, but I know that a lot of people in the United States use Verabar. And so this is kind of how IDDSI flow test matches up with the Verabar barium products for thin nectar, thin honey, and honey. And the results show that Verabar thin tests within a level 0, which is a thin on the IDDSI framework, meaning that the entire 10 milliliters of the sample flowed out of the syringe in less than 10 seconds. Verabar nectar tested within the mildly thick nectar range, and the Verabar thin honey tested close to the upper boundary of the moderately thick range. And so when you see these results, it's really exciting that all of the IDDSI consistency levels fit with the Verabar liquid, so that many SLPs in the USA can use this quite easily, can use IDDSI. The Verabar honey results in table 2 are shown with a question mark and probable classification as an IDDSI level 4, extremely thick liquid. This product was observed to produce about 2 to 3 drops from the syringe within that 10-second test period. When this sort of result is seen, it means again that the liquid is testing right at the boundary between moderately and extremely thick. And so it's really too thick to be tested using that syringe flow test. And so the IDDSI framework testing method instructions suggest that a spoon tilt or a fork drip test should be done to confirm flow characteristics at this level. And so this is something I'll also talk about. And it's important to note that if you're using Verabar, and that's what your hospital uses, you have one step done, which is the creation of your IDDSI level consistencies for testing purposes. So now you'll want to make matching liquids that you can then offer your patients after their video for home and hospital use. So what you would be able to offer them in-house according to the recommendations that you've seen given their results on video. And so there's one thing that was missing from the previous slide, and that was the level 1 slightly thick liquid. This recipe for level 1 slightly thick Verabar can be found on the slide. And so after this, now we have the full range of IDDSI liquids for Verabar user with really little to no alterations and very little prep. So 50% Verabar thin mixed with half Verabar nectar should then give you a slightly thick using the two Verabar products. And so we recently published an article that provides recipes with instructions and weight and grams for xanthan and starch thickeners with and without contrast. This article is open access in dysphagia and really provides clinicians with an excellent starting point in terms of thickening for video fluoroscopy and then taking those results to map to diet recommendations. So here I have IDDSI levels, barium and non-barium, and these are matched recipes. So you have recipes for your video, your contrast, and then you have recipes for your recommendations after the video. Because of the setting, the temperature and the wait time after mixing are all also really important factors that that really impact flow. So I'd suggest to use these recipes as guidelines for creating your own consistent in-house recipes. So essentially think of them as starting points for your own recipes. If you don't have any IDDSI recipes and are looking to transition, this might be a good starting point. Also to start here, really make your barium recipes, and once you cut the contrast, you'll most likely have to add more thickener to the barium version, as you see here. So it's interesting to see the stark difference in the gum to starch for the non-barium. So we can really see essentially how much barium really decreases the flow of liquids. So this is why it's so important to ensure synchrony of our liquids from video to in-home and hospital. It's extremely important. And these recipes, I have to note, are also 20% weight to volume barium. I know that the Verabar are 40. In our lab, we like to use 20, so the least amount of barium, but with still the most radiopacity that we can get, but without barium kind of impacting the flow and the coating of the mucosa seen in video. I'm just going to kind of touch a little bit on the fork and spoon tests, and then I will be done. So you might find that the flow test doesn't work for liquids that are thicker. If you're having trouble loading the syringe because of thickness and you're getting your material sticking to the syringe, not dropping and becoming level like you saw in that pudding that I demonstrated, you may have to transition to the spoon and fork tests for those higher levels. So the 3 and 4, moderately and extremely thick. So as I mentioned previously, using the fork, look to see, the coating both above and below the fork as shown on the slide. So level 4 will usually end up with a mound that will sit above the fork and a small tail underneath the fork. Whereas you can see above in a level 3 with the fork test, you'll have a very small mound above the fork and a thick long tail that will consistently drip. Whereas the spoon test on the right-hand side of the screen, the moderately thick liquid flows off of the spoon and really spreads out when it hits the surface of, if you're testing on a table or a plate, it will spread. Where this extremely thick, or the green box that you can see on the right, plops off of the spoon. And at times it actually might require a little flick to get the liquid moving, but it usually plops and then will sit in a mound on the flat surface that you're flicking it onto. So these show an example of the fork drip test. You can see that level 3 drips in strands again through the fork prongs, while level 4 sits in that mound above the fork. And again, there might be a little tiny tail below the fork, but really the test stimuli don't really drip continuously through those prongs. And the spoon tilt test, This is kind of just another image. It also looks at cohesion and the stickiness of a texture. And again, with level 3 flowing off of the spoon and level 4 plopping in one dollop off of the spoon. And so the bolus should be cohesive enough to hold its shape. However, it shouldn't be sticky. Like you can see here in the peanut butter, you have a lot of residue left on the spoon. That's too sticky. So one of the interim steps that we believe might be helpful is develop what they're IDDSI is calling currency converters to help clinicians and facilities map from current practice to the new framework. And so on this slide, it just might be helpful. That's why I decided to share it with you. We're showing the expected currency conversion from what a lot of us were previously using, the national dysphagia diet categories, which can be seen on the left, if that's what you're using, to the IDDSI framework for the drinks on the right. So these are the texture modified liquids. So that might be helpful. And then just in terms of mapping texture modification recommendations, I've included some tips here to help with mapping recommendations for patients after their video and after you know what texture you'll be having them mix. And really what you can do is actually have some standard recipes for them to go home with that fit all of those, IDDSI categories. And then that way they'll be able to make something and be consistent with knowing what their expectations are. And then this may help in terms of them creating their own recipes in the future. And so in the hospital, I highly recommend creating a kit with proper syringes, for the patients, and practicing in-house with demonstration, using their kit with them, pulling out syringes, using thickeners, things like that. Providing links is really important. And again, recipes based on their outcomes on the IDDSI framework. And I find really helpful having the framework on hand. In the lab, I have it on every surface almost. So it's, really a great reference. At home, it's important to really encourage testing for familiarization, even though you're giving them perhaps a slightly thick liquid recipe for a smoothie. Really, hit home that it's important for them to be doing their own testing and their own kind of calibration at home as well. And providing all of those resources ahead of time really helps. I'd encourage check-ins, perhaps sharing different recipes with back and forth with clinicians, other patients, and really having visuals that they can put up at home. Again, that IDDSI framework would be great. And so this is kind of what I would recommend in terms of a take-home package. Once you've demonstrated the test, have the patient and family try on their own while you're there, just to kind of intervene with, in case they have questions and troubleshooting, things like that. Tip sheets help. Recipes, fact sheets, sheets with visuals for replication, different tips in terms of adding, your water to, or your thickener to water, and an overall sheet I would recommend with their target based on the current framework. So like saying, you are here outlining this red box, this is what we're targeting, and then having, information sheets for them on how to create these consistencies would be extremely helpful. And just to kind of close, some of the benefits of the IDDSI Flow test, I mean, there are so many. The fact that it's repeatable and you can really do it as many times as you need to, and it's helpful for contrast medium preparation. You can add in that barium, make new recipes, alter recipes. It's an easy technique. There's a lot of, levels of stickiness that can be tested. So because my pudding didn't work in the IDDSI Flow test, doesn't mean that I can't test it using the spoon tilt test, for example. Another thing that I love is that it's only a small amount of stimuli required for testing. I've done a lot of testing using a lot of stimuli and having to take that but then use it for patients. You have to make a lot of batches. So being able to make small batches that are for one person and still being able to test those with the flow test are great. It's easy to teach and learn. It's fast. It's cost effective. It's inexpensive, and it's really accessible. And so there's a lot of evidence and, you know, different resources that you can find online. There is an app. There are posters that you can find online. Here they are here. Here's their website, www.idsi.org. And then also some companies are coming out with new labeling systems that include IDDSI. And so that will be also really, really helpful for patients. There's actually another article that I wrote with Dr. Steele that's on Dysphagia Cafe that also kind of mirrors a lot of what I've said tonight. And with that, I will close. I just like to thank you so much for tuning in. I also have to thank the IDDSI board for the opportunity to really share my experience. They're changing the game for our field and for our patients, and the initiative is something I wholeheartedly believe in. So thank you, IDDSI, for your work, and thank you.
Thank you very much. Thank you very much, Carly. We will now open it up for a Q&A period. And just a reminder, if you're listening in, you can submit your question through the Q&A button at the bottom of your screen in the middle section of that menu that you have. Katrina, I think we have you on the call today, and you were going to answer Holly's question about the Nestle Thicken Up.
Yes, can you hear me, Alan? I'm not sure if my microphone is working.
Yes, we can hear you.
So the question that came in from Holly was that often reps from Nestle in particular regarding the Thicken Up Clear, which is a xanthan gum, will provide instructions to put the powder dry in the cup and then add the water. And I've certainly had discussions with reps about this instruction versus the opposite instruction, which is to add the powder to the liquid. And I found that they vary, that the reps vary. And in discussion with Nestle, and I think this would apply to the other powdered thickeners as well, I've learned that indeed this thing that Carly mentioned about adding the powder to a moving liquid is in fact the preferred method. So I just thought for clinicians who are wondering, how on earth do you do that? How do I get my liquid moving? It's probably worth explaining that in our lab, we use a kitchen stand mixer. So we actually put our liquid in the mixing bowl and we turn the mixer on, and then we add the liquid. It's a very useful and practical way of doing it. And certainly if you're working in a kitchen, you probably have mixers available. But that's what Carly means when she says adding it to a moving liquid.
Mm-hmm.
Thanks, Katrina. Carly, are you able to see the Q&As that are being submitted?
No. Let's see.
Okay, so if anyone from the board would like to take a stab at these questions that are being submitted through the Q&A.
Do I just click more? Oh, here we go.
Can you see them now?
Yeah.
Perfect. Julie, I know we have you on the call, so if you'd like to pitch in, please do. Just while Carly gets a chance to look at these questions that are being submitted.
Sure, thanks, Alan. I did actually want to just quickly also let people know if we've got people listening from outside of North America, just to let you know that the syringe codes that have been provided there are for North America. We've got different BD syringe codes in different parts of the world. I might have a stab at the question here. What happens if you're making a recipe and the flow test value consistently falls on the borderline between one level and another? So if you've done, as Carly and Katrina suggest, and done your 3 or 4 measures and you're consistently getting it there, what it's telling you is that that liquid is neither one level or the other level. So it's not classifiable. So you either need to thin it out or add more thickener to push it into one of the categories there.
Great, thanks, Julie. Carly, are you able to see these questions now?
Yeah, I am. I think Peter
Perfect.
wanted to answer one of them as well. Oh, Peter?
There was a question from Heather about, from a dietitian's perspective, what are recommendations for an institution new to IDDSI to get started with recipes in their kitchen? And are there recipes already available using specific types of thickeners? What we can tell you is that the manufacturers are frantically working and testing their current recipes. And in North America, we have been assured that they are all targeting January of 2019 to have recipes available to all IDDSI users in the North American area. We know that the recipes are already developed and being circulated in the United Kingdom area, throughout some parts of Europe. And I think, Julie, if you can comment on Australia, there are some companies that already are putting out equivalencies in Australia as well. Is that correct?
Actually, a lot of the Australian companies, there are no real changes to the mixing instructions. So as you come to look at them, there aren't any issues there.
Yeah, and then in terms of how do you get started with testing recipes in your kitchen, on the IDDSI website in our resources page, you will see that there is a section under implementation where we have the audit sheets available for each of the IDDSI levels. Those are downloadable. And that would be a really great place to start for anybody who is just starting to think about mapping their current menu items, their current liquids. And that way you would be able to then start to match what you have available in your sites now to what the IDDSI levels would be, and also identify the ones that are not, and think about then how can you work with those recipes to help them meet the IDDSI descriptions and testing methods. So hopefully that's helpful. Heather, thank you for that question. And then Heather, you also asked, will there be any future presentations on the food part of the pyramid? Yes, definitely join us for the October webinars. We do have James Ball and Preston Walker from the United Kingdom, and they will both be on the webinar with us to give us some really, really wonderful tips around the myths and truths of preparing texture modified foods. So watch for the announcements. That should be coming out shortly.
Thanks, Peter. Katrina, do you want to go ahead with the question from Mary?
So I was going to respond to Mary's question about, do we need to test any pre-thickened products that we already purchase? I think my answer would be yes. It's always a good idea to test and confirm the consistency of a product that you have purchased, and also a product that you've made in the kitchen may change over time. So one of the beauties of this test is that it can be repeated and can give you information at the point of service. Just one comment here, that a lot of products that have been labeled nectar historically are on the very upper boundary of what we used to call nectar. They're quite thick. And so you may discover that they actually test thicker than you are expecting. And indeed, the honey labeled products may test extremely thick. And this is one of the areas that Carly's work on adding barium is so important, because when barium is added to starch thickened liquids, one of the known phenomena is that there's a further reaction that happens and they thicken beyond their original thickness. So again, I would recommend testing and confirming. As Peter has said, though, we know that most of our industry partners are frantically testing their products and are in the process of relabeling. So we hope that a year from now, the labels will have moved to IDDSI, and that indeed when people test, there will be no surprises.
Katrina, can I add as well? I agree with you about the testing of commercially pre-thickened products as well. Also, just to consider things like batch-to-batch variability, or if something's close to its use-by date, for example, you might just want to check it. And how often would you do it? I guess as often as you're currently doing it, or in those sorts of instances.
Julie, I might just mention an example from our hospital where they were concerned about the thickening of nutritional supplements, which are difficult to thicken because of the proteins in the liquids, and we know that they can be finicky. And they actually worked on their recipes and refined their recipes and implemented a flow test on the belt line to confirm. So that's a really nice example of where they test that regularly to make sure that it is adhering to the expected thickness.
Fantastic.
And also, I would probably add in terms of temperature as well. I think we've seen in our lab too, when we're doing video fluoro prep, differences in flow for pre-thickened liquids, depending on whether it's been refrigerated or not.
Thanks, Carly. Thanks, Serena. Thanks, Julie. We only have a few minutes left, so I just want to make sure that we answer as many questions as possible. So, Jan, you wanted to answer 2 of those questions as well?
Sure. Yeah. Thanks, Alan. So I was going to address a couple of the questions in regard to pediatrics. And Laura, your question about the thought of thickener versus naturally thick fluid is probably a little complex to actually have a one-word answer to it. I think it really is obviously going to depend a lot on what age you're looking at and what kind of medical history of the child is going to be. Family preference is another thing that will come into there. And certainly there's been a lot in the literature and concerns regarding children with developing neck, young little ones, especially premature babies. So those are obviously things that as an organization, it's important to have the discussions and make some of the decisions around that. So use of thickeners versus not. Some families choose not to and would prefer to go with naturally thick. So I think it's a preference. I think the beauty of the flow test is you can test any kind of fluid. So you can still teach your family those, the testing methods, and you can still make your recommendations, and the family can still check to make sure that the thickness level is what has been recommended. So there are some good articles. A colleague of mine did a cross-country sort of survey on use of thickeners in pediatric populations. It was published in Dysphagia probably about a year or so ago. And the author is Stephanie Dion, if you're interested in taking a look at that article. And I also noted Rebecca had some questions, considerations about applying this to pediatrics. Certainly, Rebecca, if you're talking about the use of the flow test, there's no problem with that. I'm not sure if your question was related more to the barium stuff, in which case Carly or Katrina may wish to comment on that. So you certainly can use the flow test, no problem with that. And we definitely use it in our pediatric settings. Julie, I don't know if you'd like to add anything to that as well. I know you have a lot of pediatric experience.
Jan, I think you've answered them beautifully. I will say there's a question there from Laura that just taps into that, though, because it's also about infant formula too. So noting high variability when testing infant formula, with each formula needing to be tested and recipes modified, especially formulas such as pure amino. So any of those hydrolyzed formulas, for example, have quite different chemical composition, and where we were talking earlier on about proteins, etc. that those variabilities have actually always existed. It's just that you now have a device that's showing you that that variability is there, and that there are just slightly different recipes that are required to make sure that the formula is thickened to the consistency that you wish for it to be thickened to. So as I say, that's a variability based on the actual infant formula and the composition of that.
Thanks, Julie. I think we have 3 more questions. So we maybe can do a rapid round of answers. That'd be great, so that we can let people go. How often do tests need to be done in SNFs if using commercially thickened products? Anyone? Hello, anyone who would like to take a stab at that?
I was going to nominate Peter for that one, but I think that I would recommend running some tests for initially on your commercially thickened products to check that they fall where expected, and then perhaps quarterly, just to check that there hasn't been a change. There shouldn't be changes, although we expect some small variation across batches.
Thanks, Katrina. Carly, maybe this one's for you. With a 0.2 milliliter difference, should I round up or round down? Asks Amaka.
I guess it really depends on your average, really. If it's a negligible difference, I mean, Julie had answered it before when she had said that, you know, if you're on the cusp, really, then you're neither here nor there. So it might be important to kind of decrease your thickener or increase your thickener depending on what you like to target. But in terms of an average, if you're 4.2, then you've extended into that next, you know, cusp of mildly thick liquid. So, I mean, I don't know if anybody else wants to touch on that, but in terms of my averages that I get, I don't really change a recipe unless my tests are, you know, widely variable.
Carly, the other thing I think people need to recognize is the fact that the thickness of a liquid may actually change with temperature.
Yeah.
I think there was a question someone had asked, you know, are we assuming that we should be doing these tests at room temperature? And the answer is no. The testing should be done at the temperature where the product is served.
Yeah.
So you would probably need to determine what the average temperature is from the time that the product is served to the point when the person is able to consume it. And it's important to look at the possibility that there might be a change in that particular product over the course of consumption. The other thing to keep in mind is if you're still using a starch-based thickener, there will be an impact from the saliva. The salivary amylase will break down the starch thickening power, and the product may actually thin out over the course of the meal. So that's something else to keep in mind, and that's the reason why IDDSI presented the world with the IDDSI Flow test, in order that we can check the liquid thickness throughout the course of a meal if you're in the midst of doing an assessment for QA purposes, whether it's commercially thickened or something that's thickened in-house, or something that's prepared even without thickener. You know, we encourage you to make use of the flow test in order to be able to determine the thickness level of the liquids that you're serving and that your patients are receiving.
Yeah, absolutely. Even, I mean, time to test post-mixing, if you're using starch as well, even waiting that 20-minute window for it to kind of stabilize. So yeah, I completely agree, Peter. Good point.
This is Katrina. I'll just jump in and say that one of the most poignant examples I've heard of this is with baby formula, that where moms are usually instructed to heat the formula before serving, but then a baby with dysphagia may take much longer than a healthy baby to consume that liquid. And given that extra time, the liquid may cool down and it may change its consistency as a function of that temperature and time change. And so the flow test can be used if mom notices that the baby's having more difficulty later in the feed, and perhaps that will give information to explain the difficulty the baby's having.
Perfect. Thank you, Katrina. I think we have to end our session for the day. Obviously, there's a lot of questions. People are very interested in this topic, but just to respect everyone's time, we are going to mark the end of this webinar, and we'll do our best to include all of these questions on our website when the recording of this webinar is uploaded. So thank you very much, everyone, for joining us. This webinar has been recorded, and it will be available on our website at the end of the week, as well as on our YouTube channel. And if you know of anyone who'd benefit or would be interested in the contents of the webinar, please share the recording with them. Thank you again to Carly for her informative presentation, and to the board of directors from IDDSI who are able to join us today. And especially thank you to all the listeners for joining us this evening or this afternoon. We hope that you find this information useful in your practice and in your process of implementing IDDSI. We are signing off. Have a great rest of your day and week, and until next time, thank you very much.